Welcome back. I'm here with a new interesting topic, quantum gates and qubits. In this lecture, I'll give a brief introduction about what are quantum gates, how quantum gates help to build a quantum circuit, what does qubits perform in the quantum gates, and what is superposition again. Okay, now let us understand a small introduction about qubits again. Sorry. Classical bit. In classical bit, what happens? The output will be either 0 or 1. Okay, but why we need to have qubit? What does it do? Because qubit can be in superposition of states. Superposition refers to the probability of existence in both the states is equal. Okay, we'll just go through with the superposition equation. I have discussed this in earlier class also. Yeah, psi of 1 by root 2 ground state plus 1 by root 2 excited state. Okay. What is 1 by root 2 and 1 by root 2 here? The first 1 by root 2 refers to alpha and the second one refers to beta. What are alpha and beta? Alpha and beta are the probability of amplitudes. Okay. That means the probability of getting 0 state is 1 by root 2 and the probability of getting 1 state is also 1 by root 2. Okay, good. This means there is a 50% chances for each for each state. That means 0 state or 1 state. Okay, so let's just verify it. So we know that when can we tell that quantum state is in superposition? When it satisfies alpha square plus beta square equals to 1. If this condition satisfies, then we can tell that our equation is in superposition. That means what is the value of alpha square? 1 by root 2 whole square plus 1 by root 2 whole square. What happens here? That equal to 1 by 2 plus 1 by 2. Since both the denominators are same, we'll add up the numerators. That is 2 by 2. That is equal to 1. So the condition is satisfied. Okay. Now we'll move on to the next topic. Quantum gate operation cycle. So here we'll understand how the quantum gate operation works. First, we need to apply a gate. That means to perform any operation, we need to apply gates. In quantum computing, we are having Hadamard Gate, Z Gate, Y Gate, X Gate, and so on. We'll see about these gates in detail in further classes. As of now, just remember that we are going to apply a gate. Then we'll manipulate the qubits. That means once you apply any gate, what happens? The operation of the gates will be changed. The state of the gates will be different. It will get manipulated. That means what happens here? It will alter the state of a qubits through rotation and entanglement. Next, third step, we'll observe the outcome. That means you will use measurement here. In quantum computing, we use measurement to observe our outcome. To observe our outcome. Next, repeat the process until we achieve our desired states. Quite. Yes. These are the overview of, it's just an overview. It is the overview of quantum gate types and its operations. Okay. So we can see we're having a CNOT gate, phase gates, rotation gates, NOT gate, Hadamard gate, Pauli gate, and so on. Still we have Pauli gate. Okay. Now what happens in CNOT gate? Entangles two qubits. That means we are going to work on two qubits in CNOT gate. Phase gates applies a phase to qubits. Remember what will this is quite interesting topic. We'll see the phase gate in next lecture. Then rotation qubits on axis. So we'll be having x-axis, y-axis, z-axis. We'll apply the each gate and we'll understand what happens in x-axis gate, y-axis gate, and z-axis gate. It's not x-axis, actually rotational x, rotational y, rotational z. NOT gate. NOT gate is similar to the logical gate. Flips the state of the qubit. For qubit is having a zeroth state, it will flips it to one state. Okay. Hadamard Gate creates superposition of qubits. That means if you apply the Hadamard Gate, it will give a input of, it will result in output of superposed state. That means both the amplitudes will be having equal probability. Pauli gate applies a phase flip to qubits. Okay. In what happens in the phase gate? It only applies a phase to the qubits. Here in Pauli gate, it will flip the phase of the qubits. Okay. That's all for the day. In our next lecture, we'll focus on how each quantum gate works. Thanks for watching. Until then, do subscribe, like, share, comment. Thank you.